Okay, this video tutorial looks at the linear and non-linear relationships strand of mathematics, and more specifically we're going to focus on finding the equation of a line given various information about that line. So when finding the equation of a line, you really need to know two things. One of them is you need to know the y-intercept, and the other one, you need to know the gradient. If you know the gradient and the y-intercept, then you'll know the equation of any line. All right, but we're going to look at an example where you know the gradient, but you don't know the y-intercept, and we're going to talk about how you would find that out. So remember that the equation of a line is y equals mx plus c. Remember, this is the gradient intercept form. And we're going to use this form to figure out what the y-intercept might be. So, as an example, what is the equation of a line with point 2, 3 and a gradient of 2? Well, we know that the equation must be y equals 2x, because the gradient is 2, plus c. We don't know what c is, but we're going to try and figure it out. And we can figure it out using our point, because in our point, this is our x value, and that's our y value. So now we're going to substitute those values in. So this becomes 3 equals 2 lots of 2 plus c. Now 3 equals 4 plus c, therefore c must equal minus 1. So our our equation of this line would be y equals 2x take 1. So we've essentially substituted our x and our y values back into the equation in order to find c. Let's have a look at another example. It says, what is the equation of a line with a gradient of minus 3 and a point 3 minus 2? So remember again, these are our x and y values. Our equation for the line is y equals negative 3x, because negative 3 is our gradient, plus c. I'm just running out of room, that's why I'm doing the arrows like this, but I'm now going to substitute my values in. So negative 2 equals negative 3 lots of 3 plus c. Negative 2 therefore equals negative 9 plus c. Therefore c is going to equal positive 7. Therefore my equation would be y equals minus 3x plus 7. So we just looked at finding the equation of a line using the gradient and a point. But this time we're going to look at how you find the equation of a line using a point and the y-intercept. Now, one way you can do it is to determine the gradient, because anytime you have the y-intercept is always a point. Okay, it's always 0, y, all right, whatever the y value is. So if we look at our first example, we've got what is the equation of the line with a point 2, 5 and a y-intercept of 3. Well, this point, the y-intercept of 3 is actually the point 0, 3, where our x is 0 and our y is 3. In this particular case, x2 and y2, because our first point, which is 2, 5, would be x1 and y1. And remember that the gradient formula is y2 take y1 over x2 take x1. So I could use those 2 points to work out my gradient. My gradient therefore would be 3 take 5 over 0 take 2, which would essentially be negative 2 over negative 2. Therefore my gradient would be 1, and therefore I would say y equals x plus 3. Now a second way you could do it is essentially just substitute your points in using the y equals mx plus c formula. So for example, y equals, we don't know the gradient, so we've got mx plus c. Therefore 5, which is our y value from our point, equals m2 plus 3. Now, if I solve it like this, I end up with 5 equaling 2m plus 3. I can solve the linear equation. I'll rewrite my steps up here so you can see what I'm doing. 5 equals 2m plus 3. I'm going to take 3 from both sides. Therefore, 2 equals 2m. Divide by 2 on both sides. Therefore, m equals 1. So you can see that we've got the same value by doing it either way. So let's look at our second example. We've got a point of -1, -3, and a y-intercept of -4. So remember, this point would be 0, -4. We can use our equation. Okay, so let's use the equation. We're going to substitute our values in, and we end up with m equaling -4 take -3 all over 0 take -1, which becomes -4 plus 3, which is -1 over 1. So therefore our gradient is -1. So our equation would be -x take 4. But we can also do that by substituting our values in. So we've got y equals mx plus c. I'm going to put my values in that I know. I'm going to put -3 because that's my y value of the point they've given me, equals m lots of -1 take 4, because -4 is the c value that they've given me over here. So this becomes -3 equaling negative m take 4. If I plus 4 to both sides, I end up with 1 equaling -m. Divide by -1, I end up with -1 equaling m. Okay, we've got the same answer, so therefore I can just say y equals -1x, or just -x, take 4. And we end up with the exact same equation. Now the last thing you're going to need to know is how to find the equation of a line using 2 points. All right, with this particular example, we need to use the gradient formula, all right, because we don't know the y-intercept. So we need to make sure we're using this formula up here to find the gradient, and then we know the gradient, we know a point, we can do something very similar to what we did in our first example. So let's have a look at these examples. First one says, right, what is the equation of a line that connects 2, 3, and 4, 7? So remember, x1, y1, x2, y2. Gradient is y2, take y1, over x2, take x1, which becomes 4 over 2, which is 2. Now, I now have y equals 2x plus c. I don't know what c is, I've got to work that out. But I substitute either point, it doesn't matter. I'm going to use the first point. 3, therefore, would equal 2 lots of 2 plus c. This is going to be very similar to one we've had, I think. 3 equals 4 plus c. Therefore, c must equal -1. And the equation must be y equals 2x, take 1. Again, if I'm going to do that for my second point, I'll use a different color. M equals y2 take y1. So if I've got x1, y1, x2, y2, y2 take away y1 over x2 take away x1, it's going to be 6 over 6, which is just simply 1. So then I have y equals mx plus c, where m is 1, so this just becomes y equals x plus c. I can substitute a value in, and I end up with -5 equaling -2 plus c. If I add 2 to both sides, that gives me -3 equaling c. Therefore, my equation is y equals x, take 3. Okay, so here are some practice questions I would like you to have a go at. They're very similar to the ones we've gone through. So feel free to pause the video, have a go at them. When you think you've got them correct, continue the video and we'll see how you went. Okay, so let's see how you went. First example, well, first question, we've got y equals 2x plus c, because our gradient is 2. We then substituted our x and our y values in, so we ended up with 6 equal 2 lots of 2 plus c. This was 4, 6 equaled 4 plus c, therefore c equaled 2. Therefore our equation was y equals 2x plus 2. In our second example, I'm going to not worry about using the gradient formula. I'm going to substitute straight in to my equation. So I have y equals mx plus c. I've got 5 equals negative 2m plus 3. If we take 3, we end up with 2 equaling negative 2m. Therefore, m equals negative 1. Therefore, my equation was y equals negative x plus 3. And the last one, I've got my x1 and y1 values, x2 and y2 values. First thing I need to do is find out the gradient. So I've got 5, take negative 5, all over 2, take negative 3, which gives me 10 over 5, which gives me a gradient of 2. I now do something very similar like I did in the top question. Y equals 2x plus c. I substitute a value in. I might use the positive numbers here just to make it a little bit easier. 5 equals 2 lots of 2 plus c. 5 equals 4 plus c. Therefore, c must equal 1. Therefore, my equation is y equals 2x plus 1.